thing you should remember few things actually. So mainly, what are the things new in the just a minute. Yep. What are the things new in the MySQL 8 and what are the things deprecated in 5.7? That is the only one thing. Especially if anyone talking about MySQL 8, one is data dictionary. Earlier, data dictionary tables are non-transactional. It's stored like a distributed data. Now it's completely transactional data. So if you want to fetch the data from any metadata tables, it is very faster. And the second thing actually, earlier DDL operations, DML operations, DDL statements actually. DDL statements combines the data dictionary updates, storage engine operations, and binary log writes associated with DDL operation into single file. Earlier, one small difference is there. For example, your operations are there, right? Your operations writing as a separate entity. Storage engine operations, separate entity. Data dictionary updates, separate entity actually. But due to this atomic data definition language, complete all the things will be treated as a single unit, single operation actually. Okay, so that is the one internal purpose, especially internal purpose. As a DBA, you will not get more benefit. Even though you are getting benefit, you will not feel that impact actually. Okay, and one more thing, upgrade procedure. Earlier minor upgrade, whenever we are running the minor upgrade, simply remove the old binaries, install the new binaries, then starting services. That is the old approach. After that, mandatory, we need to run the MySQL_upgrade utility manually. Then only dictionary tables will be upgraded earlier. But now you no need to run. Just stop the service, uninstall the old software, install the new software, start the services. Enough. While starting, automatically it will update the data dictionary tables actually. Session reuse anyway. It came new, and security and account management, grant tables, few optimization they done actually. Password part also they have done, and table encryption also they have done. So today we are jumping into the architecture part. Don't expect architecture like a PostgreSQL and Oracle architecture. Why I am saying this one? PostgreSQL and Oracle, you have a default process, right? Child processes. Pmon, Smon, Mmon, like that, check pointer process. Lot of default processes are there in Oracle. In the PostgreSQL also I have BG writer, wall writer, check pointer, these kind of processes are there. But Oracle not like that, only one process. MySQL D process is there. It will take complete responsibility. Checkpoints, log writing, log flushing, data files flushing, everything completely handled by one MySQL D thread process only. So there is no specific architecture for MySQL, but still one flow will be there, right? Query execution flow. If you are coming to MySQL architecture, client will be there, either GUI or CLI. See, client will be there, either GUI, graphical tool, or either client, this one actually, command level, or else web server. Any of the tools, we can treat it like a client. From there, first user will execute the connection. I told, right? By default, connection reuse. Connection pool is there in the MySQL. Once it gets your request actually, so first, before coming to here only, internally it will perform authentication, whether so-and-so user logging from correct IP or not, whether is connecting to correct database or not, these things, it will check actually authentication. First it will check authentication, not authorization. Authentication is different, authorization is different. Authentication means user is authorized to come in or not, okay? That is authentication. Correct password should be there. He should enter the correct password. Once connection authorized, for his connection, one process ID will create. Anyway, we have connection purpose process, right? It will use the existing process ID. Then it will start, keep in mute please. Then it will start doing the parsing. What is the parsing actually? It will split the query. Actually, I added two. I no need to add two actually. Once process ID created, it will check for the permissions. For example, Rambabu user running C. Small example I will tell you here. For example, Rambabu is the user, okay? Rambabu user, he want to connect to database name test database, test DB, okay? From the client IP, that means Rambabu laptop IP. Rambabu laptop IP 192.168.10.11, for example, okay? 10. This one. Now, this guy is running the query from one of the client machine actually, correct, right? To access database server, definitely you need a client interface. Like for booking the movie tickets, we have this one, right? Book My Show is there, ticket counter is there, Paytm is there, lot of ways are there to book the ticket. Here also same way, if any user want to run the query, he also has lot of ways to access the database server by running his queries, right? In the same fashion, we have lot of clients. I'll come to there. Wait for some time. Okay, first this guy will raise the request, right? This complete set, I will call it as a, for example, C. He is running the query, select star from employee. Okay, this is the query. If he is running this query, this complete set, I will call it as a request, right? Complete set, we call it as a request. This request will reach us to the MySQL server first. So once done, here connection authorization will be done actually. Authentication, sorry. Authentication will be performed. Authentication means just like PGHBA, TNS names.vara, PGHBA in PostgreSQL, TNS names.vara in Oracle, right? Like two files, it will do the authentication, whether user is authorized to access or not, okay? Access the database or not. Once authentication performed, for this request, one process ID will create, then it will check immediately whether, see, whether user Rambabu has access to which table? Employee table or not, right? Employee table or not. That is the first thing it will check. Permissions. So here what it will check actually in authentication, user should enter correct password. Forget about password. It will take care about password later. First, user connecting from authorized. What authorized? Any idea? Client server, right? That means Rambabu laptop IP already is there in the MySQL configuration or not. That is important. For example, Rambabu want to connect MySQL server. Satish want to connect MySQL server. First, either Rambabu IP and Satish IP both should be listed in the MySQL configuration part actually. Okay, we'll see that. So first thing, client server is whitelisted or not? From authorized client server or not? Second thing, correct password. He is entering correct password or not? Okay, this is, we'll call it as authentication. Next thing, authorization means whether Rambabu has select access. So doing select operation, right? Select access on employee table or not, it will check actually. After that, this query internally, parsing tree will be there. If it is a simple query, okay. If it is a multiple subqueries, nested joins is there, right? Parsing tree, main thing is it will split the query into pieces, right? Slices. It will make like a chunks actually. Each chunk will be handled independently. Later, once the result set is ready, it will merge the result set together and it will display to the end user. Okay. So first splitting, then my optimizer will generate the execution plan, which is the best least cost execution plan. My optimizer will generate. Once plan generated, that plan will be handed over to executor. We will call this guy as a dispatcher, right? So this guy, what he will do, you know, whenever plan is generated, according to the plan, from where he will get the data? Normally, where he will get the data, dispatcher? Hello?
Yeah.
From the disk, right?
Yes.
From the disk, actually, he will get the data. But if you see Oracle or PostgreSQL, on the disk only, we are storing data in one fashion, right? But coming to MySQL, not like that. It's a multi-layer one actually. One guy can use different type of storage mechanism. Another guy can use different type of storage mechanism like that actually. Okay. So that multiple options provided by MySQL, they have different storage engines. InnoDB, MyISM, memory, CSV, archive, NDB, federated, like some engines are there actually. 1 minute. So see this one, these engines are there, we'll see one by one, we'll cover actually. So if your data related to InnoDB file system, it will take the data from there. If it is related to MyISM, from the respective table, it will take the data like that actually. Okay. So different storage engines are there. From there, it will get the data and it will display to the end user. Okay. Now for your information, why I have not covered a query cache. Normally query cache, where it will become? Any idea query cache? If my query cache is there, before parsing tree is there, right? So it will not split the my query as a chunks. Optimizer no need to generate execution plan. My dispatcher no need to touch the storage engines to get the data. Nothing should be required. Directly, whenever it checked whether user has select permission or not, immediately it will go to the query cache and take the result set. Whenever you have executed previously, right? Whatever the queries previously executed, all the queries result sets will be available in the cache. See, simple thing I'll tell you. I will share the diagrams as well.
Just like result cache in Oracle.
Correct, cache. So see, for example, here end user is there. Okay, end users, lot of end users is there. Same, lot of end users. We know that, right? First thing is few people are developers, MySQL developers. Few people, MySQL DBS, right? Few people, application team, and a few people, product users, direct product users. Anyone, right? Anyone can access the database server. These guys are the users. Users actually, database users. Database users. We'll call it as a end users, right? Normally, all users not end users. If you see here, first one is database developers. Second thing is DBS. DBS directly can access the server from remote machine also they can access, right? And one more thing, application team, almost equal to developers. Next one, product users. Product users actually. Product user means, for example, you have a ATM card, okay? Banking one. For a banking customer, you have ATM card, you have a credit card, right? If you are doing some transaction means, in different way, you are accessing the database server, correct, right? For this, you need to see my MySQL server running here. If my MySQL server running here, this is the one MySQL server running, okay? MySQL server, for example, 192.168.10.68 something actually, my MySQL server is running. Here, if this guy want to access database server, they need a client interface, right? So if coming to client interface, same thing actually. I have 3 different types like other databases. One is GUI, another one CLI, right? Command level. Another one app servers. Total 3 types of client interfaces. I will call it as a client interfaces. Okay. So now thing is actually this one graphical tool, GUI. We have a lot of graphical tools. I will come and explain. Second thing, command level interface, CLI. Command level interface, we have some utility and application servers. This is common, right? Application servers common, JBoss, Tomcat, that one application servers common. Any user, they can raise the connection from any of the place, not sure from where they will connect. They will use graphical tool or they will use either CLI, direct command level interface they will use, or else whether they will use application server directly, up to them actually. So each, for example, graphical tool or command level, whatever it is, they will have the separate IP address, right? That IP address we will call it as a, what we will call the IP address? end user, interface IP. Interface IP, we will call it as a, client IP. Okay, client IP. For example, their IP may be 192.168.10.12 something actually. Okay, 10.12 something their IP. Maybe this guy separate IP, this guy separate IP. Their request will reach us to the first actually MySQL server operating system. Whenever operating system my request reaches, what will happen in the top layer? First it will perform, just a minute, it will perform authentication actually. Here it will perform authentication. Okay, whether proper IP address is there or not, these kind of things, here authentication will be performed. Authentication will be performed. If successful, what will happen? It will create process ID, or it will assign process ID. Assign MySQL process ID. Okay, now this will reach us to first, this will check authorization. First authentication, later authorization will be performed for the respective process ID. If authentication and authorization both successful, then it will check the next step. It will check the request will check. It will check in query cache, whether query previously executed or not. Same query. If executed, it will get result set from here only. Okay, from here only, and directly it will display to the, so this device it will get from cache, and it will display the result to here actual output device. If for example actually, if query is not previously executed, this is the first time, what will happen? Then only parser will come, and optimizer will come, and dispatcher will come. End of the day, where is my storage engine? In the disk, right? In the disk I have storage engines, different storage engines. For example, see, this is one. This one will come. In the disk actually I have different storage engines. I will add one more point actually, then you will come to. Okay, so for example, these many storage engines I have actually. So here first one is InnoDB. Second one is MyISM. Third one actually I have memory. Next one CSV. Next one archive, and other things also there. Okay, it's space not enough, so other engine also there. Storage engines are there. We will call it as a pluggable engines. That means for any table, by default, if you created with one engine, later if you want to modify, you can modify the engine. So that is the reason. Pluggable means, any idea, anyone? What is pluggable? The word pluggable?
I mean, like you can plug from within the containers.
Yes, you can plug in, you can plug out, right?
Yeah.
So whenever you require, then you can plug in. Whenever you don't want, you can plug out. At the same time, easy to modify also, right? Easy to modify as well. Earlier you kept your plug in one box, later you can remove and you can keep somewhere, right? So now if you see here, this is the original disk actually. On top of the disk, storage engine will work. This is the disk. All the what will be stored available here? The disk actually. Data files, right? Index files, structure files, conf files, okay, and log files, and transaction logs. Your transaction log files, everything will be, all the physical files will be available in the disk actually. Okay, remember this point. So now when these all the things will happen actually, in middle actually I have two things. If query first time executing, what will happen here? executing, few steps will come. Few steps will come. 1 minute. 1 minute. So whenever query executing first time, few steps will come in place. Okay, come in place. What are the steps actually? So first thing is parser, right? Parser is there. Parser. Second thing, optimizer. Fourth one is actually dispatcher, right? Dispatcher. Total 3 things, additional steps coming actually. That's it. If it is a first time, if it is a, see here. So here actually parser, it will divide the query into chunks. This one actually optimizer, best execution plan it will generate. This is dispatcher. Original results it will get it actually, okay, from the disk. So now see it. All the things will be end of the day. It will work on top of the engines only. From engines, according to with respective engine, it will get the data and it will display. Here it will go. Flow will go like this. Parser to optimizer. Based on the chunks, optimizer will generate execution plan. Dispatcher will work with a respective engines. I don't know which table is related to which engine. I don't know. So according to that one, it will get it actually. Anyone tell me what is the main thing we are saving here? If my query is a second time, what will be reduced main thing? First thing, see, if query running second time,
Time.
perfect. Query running second time, first thing we can save time, right? Second thing,
Cost.
disk IO will be reduced. Why disk IO will be reduced? You no need to touch the disk, right, to get the data. Next thing, as disk IO reducing, hitting the disk and getting the data reducing means CPU usage will be reduced, right? These benefits are there actually for us. Okay, you see that MySQL given lot of options. You can identify which query using cache, which query not using cache. Sometimes my query I don't want to hit the cache. How to stop that option? That option also we have in MySQL at database level, not OS level. Okay, PostgreSQL OS level, right? Cache. But here MySQL database level option they given directly. If you want, you can enable it. If you don't want, you can disable it. Okay. But for your information in interview, definitely they will ask this question. Query cache disabled, deprecated in 5.7. 8 version, there is no query cache. Okay. Common query cache. Earlier in 5.7, with irrespective to engine. Okay. Across all engines, only one query cache is there. Earlier until 5.7. Now they deprecated it. They given engine specific. For InnoDB, they given one thing, one cache. For MyISM, they given one cache, engine specific. Okay, let me come there. So this is the way I'm getting result set. Now what I'm going to do now here actually graphical tools. See, here I told right GUI. What kind of graphical tools you have in MySQL? First tool name is there actually MySQL Workbench. This is the most popular one. Like we are using pgadmin, right? In the same manner, we have a MySQL Workbench. Why MySQL Workbench? First thing is user-friendly interface, and one more thing, it is available on Windows, Mac OS, Linux as well. And one more thing, you can able to see the server status and respective logs, error logs, general logs, slow query, slow running query logs are there, right? That things you can able to see from the MySQL Workbench. I will cover MySQL Workbench as part of our class. Not only this one, we have one more thing, Beekeeper Studio. This is also one graphical tool. Main thing actually, SQL query auto compilation actually, not completion. And one more thing, connections through firewalls, and it will work offline as well. Same thing. It is working on Windows and Mac OS, Linux operating system. For your information, all GA tools, it will work offline actually. Simple thing is they added few points, that's it. This is very nice one. DB4 Studio is there. DB4 Studio, it will generate and execute and debug the query. Query plan completely, you can able to see. You can able to take the backups as well, okay? Database backup, and you can perform the analyze operation to update the statistics on the table. You can perform analyze as well with DBForge. Okay, this one also most popular. Main thing MySQL Workbench and Healed SQL. Okay, do one thing. If anyone getting doubts in middle, ping in the chat actually. Later, all I'll explain one by one. Okay, or else some people will feel disturbance actually. I don't want to stop in the middle. So if you are getting any question, yeah, you ping in the chat. At the end, I'll explain one by one. Okay, yeah. Main thing in the market right now using most of the people either 95% is MySQL Workbench, 5% is people, not 5, at least 4 Healed SQL, remaining Navicat and all up to you actually. Okay, few, each graphical tool has its own property. Some tool is giving some extra things. That's it. Other than that, nothing is there. See, Syslog, SQL Log, SQL Yogi is there, DBAver, PHP MyAdmin is there, Toad also there. Toad, I think Oracle people aware of this one. Toad Edge for MySQL, SQL Pro also there. DBAver, PostgreSQL people aware actually. DBAver, PHP MyAdmin purely for MySQL. Okay, these are the graphical tools. Any of the graphical tools, they can directly run the query. They can connect to the database server IP. They can access database server. I told one more thing, command level interface. What is the command level interface utility? MySQL. Utility name is MySQL. For PostgreSQL, we have PSQL. For Oracle, we have SQL plus, right? In the same manner for MySQL, I have MySQL is the utility. Okay. Next thing, actually, application servers common actually. Application servers. Why I am saying common actually? JDBC, ODBC drivers, wherever they are using .NET, Java, definitely those servers are eligible. Okay. In addition to that one, this can handle PHP related servers as well. MySQL. Okay. Especially Tomcat, JBoss, something is there actually. What is that? Solar something is there. Solar is something. So few servers are there. WebSphere, especially WebSphere. Any of the server they can use based on their requirement, right? Application server. So they will use connection string from application server. Now coming to architecture part. Only overall view I told right here. This is a overview. This time we'll go one thing. Just we'll go little bit this one actually deeper. First, coming to MySQL architecture, it's divided as a 3 layers. One is client layer, another one is server layer, and another one is storage layer. Total 3 layers actually. All the 3 layers already explained here, right? So which is the client? This is the client part. Which is the server part? This authentication, authorization, parsing, optimizing. This is server side. This is storage engine, right? These are the three layers already we explained. 1 minute, let me check. Someone is being it seems any class related one. Okay. So see this one, client layer, which is the topmost layer, client layer only, right? This guy only first will come. If you see the diagram properly, if I give this is what I done actually, side by side I kept actually. For example, if I'm keeping order wise, top client, middle client interface, bottom MySQL server OS, underlying storage layer, right? Like that it will come. So that's the reason first client layer. This layer is the topmost layer. The client give request instructions to the server with the help of client layer. Up to you, graphical tool or command level tool or application server, which one you will use to access the database server, up to you. That client make request through the command prompt or GUI, whatever it is. They will send the query. They will execute the query, right? If the expressions and commands are valid, then output is obtained in the screen actually. If he is running correct query, that query will be output will be displayed in the. If you are running in the graphical tool, there only output display. If it is a command, there only it will display. If it is application server, there only it will be displaying, right? Data. And one more thing, see some important services of client layer actually. In the client layer, what are the things mainly performing? Connection handling, authentication. First it is getting request from user, right? It is going to the in the client layer only. Authentication performing, security, whether user has so and so permission on the so and so table or not, it is giving. See one by one again I have explained. When a client send request, first it will check actually. It will check whether he is connecting from authorized IP address or not. Second thing, if he is authorized, it will create a process ID for that connection. Then it will check actually whether he is connecting with correct password or not. Okay. After that only, see here, after authentication, when the client gets connected successfully to MySQL server, the server will check that particular client has the privileges to the issue certain queries against MySQL server. See, three things, right? First one is correct IP address or not. Second thing, correct password or not. Third thing, whether on the table he has a permission or not. Total three things will be there in the client layer. Okay. Next one, in the server layer. Next server layer, what I am doing actually, the second layer of MySQL architecture is responsible for all logical functionalities of tables actually. Your relational database is there, right? MySQL. All logical functionalities will be handled by my server layer. This layer of MySQL, we will call it as a brain of MySQL. See, previous one, everything physical. All are physical and just like hard work. This is the brain of MySQL architecture. Complete a way of execution will be depends and will be happened in the this part only, server layer only. So I will call server layer as a brain of MySQL architecture. And one more thing, when the client give request instructions to the server and the server gives the output as soon as the instruction is matched. Okay, correct query is there, correct permissions are there, all the things are correct, valid. So then only my server will get the data and give the result to the end user. Okay. Now in the server actually, server various subcomponents are there. Same thing I told now. See, thread handling, parser, optimizer, and query cache. These things I explained here already. You I have explained, right? If query thread handling means any query comes actually, see, that one I told whether query coming first time or second time, it will check actually. That is the first part. If everything is fine, no parser, no optimizer actually. These two will not come actually. Directly it will get from cache only. See here, coming to cache, lot of points are there, but bad thing is 5.7 only they deprecated query cache. Okay. Now 8 onwards, you don't have these options. Still, if you are getting chance to work on MySQL 5, I will share few points about query cache. Interviews definitely they will ask. If any one of you putting experience as a 4 years, something like that, definitely questions will come from MySQL 5.7. First thing actually, what is the main advantage of query cache? Cache will store already executed query result set, right? Executed query result set. If the same query running from another user, what it will do? It will get the result set from the cache. What is the main benefit? First, it is skipping, query parsing, and query optimization and query execution. All the steps simply skipping and getting the result from cache. Okay. So what is the benefit? So it will be 238% based on multiple tests. They decided, they given one round figure, 238% faster than the query without using the cache. Okay. And one more thing, whether your query cache already by default enabled or not, if you want to check, there is a parameter called actually, see here, sorry. If you want to keep more, by default actually query cache size 64 MB. If you want to keep more cache, more query numbers, more queries result sets, if you want to keep in the cache, simply you can increase this value to bigger value, query cache size. By default actually 0. Okay. By default 0 will be there. That means default value 64 MB. If you want to increase, you can increase the query cache size to bigger value. But see, sometimes it will decrease the performance. Don't think all the times getting result from cache is good. Don't think like that. What are the performance drawbacks are there? Be cautious about sizing the query cache excessively large, which increases the overhead required to maintain the cache. See, cache is there. Earlier 64 MB is there. Okay. It is maintaining only few queries. So my MySQL can take care about if any changes happening. It will go to the cache and it will mark it as a your work is done. You are not valid. Okay. You are not a valid. If new query coming, it will not treat like a already completed query. So some maintenance required for the query cache also. If you are keep on increasing the size of cache, maintenance will become little bit headache. Size in tens of MBs, 10 MB, 20 MB, 30 MB, okay. But if you are going with the GBs, sizes in hundreds of MBs means GBs. If you are going with more than 100 more than GBs, it's not a good one. Maintenance will be very difficult. And one more thing, see here. To verify that enabling query cache is beneficial, test the operation. How some people will ask, Rambabu, if I get the result set from cache, it is good or bad, how can I check it? Simple thing, without query cache, without using the query cache, run the same query. With using query cache, run the same query. Then you will get the metrics, right? Then you compare both timings, which is executing very faster, you can easily identify. Then you people are very intelligent, I know. How can I check without cache, with cache? By default, actually with cache, right? They have given two options. One is SQL no cache, another one SQL cache. Two options they given actually. Okay, SQL cache and SQL no cache. If you don't want to use the cache with your query, you can keep it. That means session level you can enable it. Set global variable SQL no cache. This one 0 means disable, 1 means enable. I will show you how to enable or disable. Okay, this one. And one more thing, already I have executed a query. How to make sure it is taken the result from cache? Very simple. I have a parameter called query hits. Okay, query hits. What I will do, first I will check the query hits number. For example, now it is showing 1000. Next time I executed one select query, then I checked this number. If it is showing same number means my query not used the cache. If it is number increased, I can decide like, okay, it is using the query cache. Like that I can decide. Okay. And one more thing for your information, if a table, see, if a table changes, all cached queries that use the table become invalid and removed from the cache. Okay. When your query will be executed, for example, here Satish is there. Satish executed select star from employee. Okay. Some data is there. Satish run second time. Satish run third time. So every time it will get the result from cache. In middle, one guy inserted data to employee table. In middle, one guy updated the employee table. In middle, one guy modified the table. Any operation, see, insert, update, delete, truncate table, alter table, drop database, any of the operation, if anyone performed immediately, whatever the cache is there, right, it will be removed from the, whatever the result set is there in the cache, simply it will be removed. Okay. Remember that one. Anyone performed any change, your query will be treated as a first time running query. Then parser, optimizer, dispatcher, everything will be come into the place for execution, right? Later, see, you may get a doubt, Rambabu, for my table, how can I get the cache ID? Very simple, this one. Select SQL cache ID actually, okay? It will print the number. Before and after you can do. If same cache number is there, you can treat like it is not using. Okay. At the same time, I can use like this. If I mention SQL cache, explicitly it will get from cache. If I using like this, it will not touch the cache. Even though cache is there, still it will not use the cache. Both the levels, so total 3 layers. One is instance level, you can disable it. Session level, you can disable it. With the query itself, you can disable by using cache. Okay. Now see here, how I can check to check query cache available or not. Whether query cache already available or not, how you will check it? You need to run this one. So variables like PostgreSQL, how you are checking any parameter value? For example, I want to see max connections. So max underscore connections, it will print the value. Oracle also same show command, right? So no, Oracle not this one, right? Show command. If you want to check the parameter, Oracle, how you will check it? I forgot. So, but in MySQL, show variables is the command actually. You can give the parameter name. See, so variables like have query catchy. Okay. When using standard MySQL binary, this value is always yes. Always query catchy will be enabled if you installed MySQL with binaries. But sometimes we will go with the yum installation, right? Default, it is disabled actually. Okay. So we'll see that. And one more thing, minimum value. Global query catchy size is there. Minimum value 40 KB will be there. Okay. 40 KB. But you can set the values in a MBs. You can set like a MBs actually with using this query. I will show you. Set global query catchy size. Okay. 10,000, something like that. 10 MB, 20 MB, like that. I will make it more than 100 MB. It's not recommended actually. Okay. And one more thing, see, even though you have enabled, you have given the size, query catchy size is there, right? Again, you have one more option, interlinked, query catchy type, okay? Query catchy type is there. Both are dependent. Even though you changed the value here, if it is disabled, it will not work, okay? Even though this is enabled, if it is 0, catchy will not work. So both parameters should be configured. If you keep value 0, query catchy type 0 actually, so it will get the completely, it will not using the catchy. If you keep value 1, then only it will start using catchy. So for your information, query catchy size, here see, query catchy size and query catchy type, both should be, both are dependent. Remember this one, both are dependent. Next one. So these are the ways we can do the query catch. Session level you can disable like this. Set session, query catch type off. I can make it like a session level as well. And one more thing actually, if you want to monitor the query catch performance, up to now how many query catches hits happened, okay, that kind of details you will get. See, show status like catchy, Q catchy. If you give this one, it will print output once I install, right? I'll show you what are the metrics coming actually, okay? And one more thing, especially few of the queries, if multiple times you are running also, every time it will treat it like a, you are executing the query first time, okay? For example, I'm running one select statement, but still every time it is treating like a first time query. My optimizer generating execution plan, my dispatcher getting data from the disk. In which cases? See, functions and stored procedures, multiple times if you run also, it will not included in the catchy, okay? For example, current day to current time stamp, internal procedure, that one, right? That one will not be considered in the catchy. Second thing actually, see, few options. User variables or local stored procedures, variables are there. That one also will not consider. System metadata tables. MySQL by default contains some tables. Information schema also contain tables. Performance schema. These are the default databases. In MySQL, I'll show you. These tables, these database related tables, right? Catching not possible. It will not utilize catching possible. And one more thing, partition tables, catching will not work. Okay. If you run select operation on any partitioning table, every time it will treats like a new query only. And one more thing, these kind of options, lock in share mode, rows for update, into output file, into dump file, these kind of things, every time it will treat like a. And one more thing, wherever auto incremental colon is there, every time, if you run multiple times also, still it will treat like a first time running query. Okay, this is query catchy. Whatever the things we discussed up to now, right? This query catchy. Is it available in MySQL 8.0? Is it available or not?
No.
No, right? With 5.7 only query catchy deprecated. So what about option 8 actually? So 8 onwards, simply they given the storage engine wise, right? If InnoDB, you can go different one. MyIsm, you can use different catchy like that. They given options actually. What options they given, we'll see. Okay. See, buffer and catchy. See, what is this? Buffer and catchy. MySQL allocates buffer and catches to improve performance of database operations. You can improve MySQL performance by increasing the values of certain catchy and buffer related system variables. And also you can modify these variables, okay, with limited. See, everyone should accept one thing. If catchy is more, if you run a multiple select operations, performance is good or bad, you have a more catchy. You are running more select operations. Performance is good or bad? Always good. If you have a more catchy,
Good.
run only select operations, always good. But don't increase. If, for example, if your system is 16 GB, don't increase like a 14 GB like that. Okay. There might be chances system server will crash actually. Okay. So first thing, what kind of buffer catchy? So with respect to main thing in MySQL, to store the data, we have two engines, InnoDB and MyIsm. These are the two main storage engines handling the data physically handling the data. Remaining memory, CSV, this is operation specific actually, requirement specific. It don't have any physical files, especially for select operations. Memory and CSV both are for select or reporting queries, archive for compression actually. So directly it will not handle the physical files. So main things handling InnoDB and MyIsm. Remember these two things. InnoDB and MyIsm only main engines. Until 5 series. Default engine is, anyone can tell? Default engine, storage engine. Until 5 series.
InnoDB.
Until 5 series actually MyIsm is the default engine, not InnoDB. MyIsm means non-transactional data. MySQL default behavior. Why MySQL first came into the picture? They store data in a non-transactional format, right? Earlier, their main motto is to store data in non-transactional format. So by default, MyIsm is the main engine. But 8 onwards, a lot of concern came actually. 8 onwards, they simply change it to InnoDB. This point, don't forget. We are seeing few people coming for interview. They are not even aware actually which is the storage engine, default storage engine. These kind of things they are not even aware. From 8 onwards, see this one. I will share this diagram. From 8 onwards, default. Okay, default storage engine. Whatever the table you are creating, default it will create with a InnoDB until this one actually MyIsm until 5 series. Okay, until 5 series. Next one. So now I'll do one thing. Let me come to here actually. InnoDB buffer pool is a memory area that holds cached InnoDB data for tables. Already I told, right? It is purely engine specific. So they given one parameter, InnoDB buffer pool actually, it is a memory area. It holds cached InnoDB data. Whatever the tables are there, right? InnoDB related, the tables data, that indexes data, that everything, whatever the details are there, right? With respect to InnoDB, everything that cache will be managed in InnoDB buffer pool only. For efficiency of high volume read operations, the buffer pool is divided into pages, C, that can potentially hold multiple rows. For efficiency of cache management, the buffer pool is C. Thing is, I will tell you one thing. My buffer pool size is there, right? It's a memory area. Buffer pool size is there. For example, this one. What is this? What is the buffer pool size name? InnoDB buffer pool size, right? Buffer pool size. It will contain a number of pages actually. Okay. In the memory buffers, we can call it as a buffers. In the disk, we will call it as a. In the disk, we'll call it as a page. In memory, we will call it as a buffer, right? So this one directly I can use it. Directly I can use it. At the same time, I can divide like a InnoDB buffer pool instances. Okay, InnoDB buffer pool instances, I can divide it. MySQL given option actually. For example, same buffer pool size. If I am dividing like a InnoDB buffer pool instances, here I have divided as a three instances, right? That means each can handle multiple threads. Okay, then what will happen? Even though concurrent queries coming, it can use more effectively. Cache will be used more effectively, right? Effectively. If all are hitting on the, for example, if single, it's like a single piece. If all are hitting, definitely getting results also will show the impact. If I'm dividing like a instance wise, see, let me show you the theory part for you. So the size of buffer pool size is, see, the size of buffer pool is important for the system performance. InnoDB allocates memory for the entire buffer pool at server startup. Okay, internally, this one malloc function is there. That one will assign the some memory for the InnoDB buffer pool size. Okay, parameter, if you want to configure the InnoDB buffer, you have a parameter called InnoDB buffer pool size. See here to configure. Theoretical way is where different and configuration is different, right? For configuration, parameter is this one, InnoDB buffer pool size. Remember this one, like Oracle SGA, system global area, PostgreSQL shared buffers. In MySQL for InnoDB, it is InnoDB buffer pool size. Okay, by default anyway, all the tables are creating with InnoDB storage engine, right? So InnoDB buffer pool size will play a key role in the performance. Recommended InnoDB buffer pool size value is 50 to 75% of the total RAM. For example, if I have system RAM is 100 GB, maximum I can assign how much? 75 GB, right? As a this value. Remember this point, okay? How much bigger you are giving, that much good performance will be there for you. And one more thing, already I told actually, okay? To improve concurrent queries performance, which are depending upon the cache, if I divide this into number 3 or number 4, number 5 like that, so performance will be little bit faster actually. Okay, and one more thing actually, a buffer pool that is too small may cause exclusive churnings as a pages are flushed from the buffer pool. See why some people asked actually, Rambabu, can we take this size InnoDB buffer pool size as very small? What will happen if I do very small? Within short time actually, lot of queries hitting, definitely disk pages will be shaked actually. Okay, it will be shaking will come. There might be chances for file system crashing. Okay, if you mention very less buffer pool size, definitely system might crash actually if all are hitting at a time. That is the reason we are maintaining some room actually. 50 to 75% is good value. InnoDB buffer pool size. What about this one? MyIsm. For MyIsm, I have a concept called key buffer size actually. Okay, for MyIsm, key buffer size. So earlier only just cache, but now it's divided as a two, InnoDB buffer pool size and key buffer size actually. Okay, so and one more thing, whether I can use it or not, how can I do that one? For that, I have a option MyIsm use mmap. MyIsm use mmap system variable can be set to 1, enable memory mapping. See, if you enable this one, then only this key buffer size will be used. If you disable it, it will not use the caching facility directly. It will go to the disk actually. Okay, and one more thing, for each MyIsm table, the server opens index file. I will come back to you. If you go with a InnoDB table creation, it will create single file. Okay, for index, for data, for dictionary, for metadata, everything single file, file per table. You might heard this concept. File per table means for one table, one file will be there. All the things will be managed in the same file. It is a good or bad? Anyone can tell me? For one table, index, data, metadata, structure, everything managing in single file. Second scenario, for single table, one data file. For index, one data file. For dictionary, one data file. Okay, one table, 3 files maintaining. Which is good one?
Maintaining 3.
Maintaining 3 is good one. Huh? What will happen if you insert data? It should update 3 files, right?
3 files. Yeah.
If you want to select data, it should select from 3 files.
3 files.
But whereas if I'm going with single table, if I'm doing selector and set, how many files I need to update?
Single file.
So which is better then?
But
Logically-
index file will be small, right? So
Always single is better actually.
Logically, single is better.
Single is better actually. Okay. I will cover that
Okay.
one. What are the benefits? What are this one we will cover actually. And one more thing. See here. We will think like only 3 files actually. Okay. But that is one file. This is 3 files only. Both are same only. I can achieve some better performance like that we will think. But for example, one table contain 3 files. That 3 files, right? In the 3 files internally, how it will occupy size actually for table structure by default for table structure actually based on the data type structure 3 buffers, column structure 3 buffers and extra 1 buffer. Total for one row it will occupy 3 buffers actually. Okay, if you are inserting 10 records, 10 into 3, 30 buffers like that actually unnecessarily it will consume. But here file per table only 1 buffer actually. Okay, no extra buffers for table and structures, no different files actually. Okay, so that is the way file per table is very nice. And one more thing for the MyIsm, if you are going with a blob gone case, each one will use actually almost 8 bytes. Okay, normal data numbers, characters, that one will go with a 3 bytes. But if you are going with a blob data type, it will consume more than 8 bytes actually. Okay, so don't go with one table, multiple files. Don't go with that approach. Go with one table, one data file. Okay, and one more thing, one more approach is there. Sometimes actually temporary tables are there, right? Temporary tables will be there. Normally for temp table also I will give one size. Temp table size should not cross a 1 GB. For example, if I given like that 1 GB, but due to some reason I am creating a more with a 2 GB size of temp table, what will happen? Whenever it reached 1 GB, immediately the temp table will be converted as a physical table and it will writing into the disk actually. So by default, it will use a MyIsm storage engine. Small thing, small confusion. Okay, don't mess up 2 concepts. I am coming here. See, first thing, as there is no cache in MySQL 8, so 2 storage engines are using 2 different caches. First one is the InnoDB buffer cache. Second one is
Key buffer cache.
key buffer cache, right? Key buffer cache. Perfect. This is one concept. Second thing, for your information, anyway, later I will explain, but any of the InnoDB tables, file per table. For one table, it will create one file. This one for one table, how many files? 3 files. Okay, 3 files will create. Next thing, different concept. In MySQL, I can prevent temp table size. I put the limit. Temp table size limit. For example, I kept 1 GB. Okay, but due to big operation, it is reaching 2 GB. Whenever it became 1 GB, anyone aware temp table behavior? Normally, if I am creating one temporary table, if I come out of the session and if I log in, the table will be available or gone?
flushed out.
Table will be
Gone.
gone, right?
Yeah.
gone actually. But thing is, if it is in MySQL, if it is crossed more than 1 GB size actually, okay, so immediately it will be converted as a physical table. Okay, default engine will be if size more than 1 GB, 1 GB becomes physical table. Physical table uses MySQL engine. Okay, like that actually later. That is temp related one. For controlling, I have a temp, this one, temp table size actually. This option is there for controlling. Okay, and one more thing actually, yeah, later, not only this one actually, each thread, whatever the process ID creating, right? That process ID internally uses some space actually. That is mandatory. Whatever the process coming, that one will use some space. For that, they have 3 variables to control the space. So and so process, I don't want to control, I don't want to use more space. How we will limit that one? They given 3 parameters. One is thread stack, another one is net buffer length, another one is, sorry, two actually. Yeah, sorry. I will explain this one later. Thread stack, connection buffer related net buffer length, result buffer. 2 buffers will be there. One is for connecting, another one is for sending result, right? So for that, one is net buffer length and another one also 2 net buffer lengths are there. And for stack, initial creating the thread, it will use the thread stack. These are the 3 parameters will control your thread actually. We will see that. I will explain what exactly this one I will explain. And one more thing, MySQL also requires memory for the table definition cache. Table definition is there, right? The table definition cache system variable defines number of table definitions. See, in which case this scenario will come? Table definition is there, right? Table definition will be stored in one file. It will come in InnoDB or MySQL. Table definition storing in a separate file. In which engine we will see this one?
MySQL.
MySQL, right? Correct. MySQL only separate files. For index, separate file. For dictionary, separate file. For data, separate file. Total 3 files actually. So in MySQL, for table definition cache separate, for data cache, for key buffer cache. Okay, that's what actually. If you have multiple tables, you can increase this value. Multiple tables cache for storing, you should increase this value, or else it will fail actually. Query assigned table definition cache size is not enough, not sufficient, something like that. It will throw error. And one more thing, MySQL, while starting working on practical things, right? You will see 2 things. You will see 2 things. One is flush table statement, okay? Another one flush privileges statement. Remember these 2. One is flush tables, another one is flush privileges. Multiple times I will run flush tables, multiple times I will run flush privileges. What exactly it will do? Flush table statement, okay? Flush table statement is there. By connecting to the MySQL command prompt, I will run this command. Whenever I'm running this one, right? Command closes all the tables that are not in use at once and marks all in use tables to be closed when the currently executing. See, thing is, MySQL bad thing is whenever you are doing some operation on so and so table, right? That file is there. Which one? Data file is there, in index file is there, dictionary file is there, right? Whenever you are running the query, files will be opened. Okay, it will not close actually. If you run the flush tables, already work completed, still files are open. That files will be closed. Second thing, query still running. Okay, once that query is completed, simply it will close all the open files actually. Okay, that is one way. It will be saving the cache size, right? All open files, definitely it will consume the cache. Whenever it's closing, immediately that cache will be released actually. And one more thing, we can make a free used cache with its freed with C. Once this one done, right, all it's closing, right? If you want to forcefully make free the cache, you can run the flush privileges. Okay, all the cache will become free. First one, just closing the all open files. Second thing, plus privileges, just making free the cache, making ready for the next usage actually. These are the main things for you. And one more thing, table metadata cache, what kind of data it will store? The metadata cache is a reserved area of memory. See, it can store databases metadata, indexes metadata, objects metadata, okay? And most of the things, it will track it actually. All the open databases information, it will track it. So you should remember these points today class, especially see what I covered: storage engines, InnoDB, MyISM, memory, CSV, archive, these engine names, and query cache parameter. As it is deprecated, I have covered InnoDB buffer pool size and key buffer size, and InnoDB tables will be file per table. MyISM tables file per, 3 files per table actually. And one more thing, if temp table size limit crossing, it will be converted as a physical table. And one more thing actually, for storing table meta dictionary data or metadata, we have a separate size. For creating only metadata, that part also we covered, right? And one more thing, yeah, these are the main things for today class. So tomorrow, all the storage engines one by one I will explain. We have lot of storage engines, okay? InnoDB, MyISM, memory, CSV, merge, archive, federated, black hole, and example. These are the storage engines, okay? And one more thing, we have 2 types of engines. One is transactional, another one is non-transactional, okay? Transactional will be suitable for OLTP, non-transactional suitable for OLAP. The default storage engine for MySQL is before 5.5 MyISM, after 5.5 I made it like a, they made it not I, they made it like a InnoDB actually. Tomorrow we will see each and every storage engine, the benefit we will see that, okay? Before closing the session, what I will do, I will cover the first questions actually one by one. Later we will close it. First one, how to check what is the default storage engine? Srikanth, I covered, right? Until 5.5 it is MyISM. Now it's changed as a InnoDB default actually, okay? And one more thing, yeah, each and every table which engine it is using, we can able to check. If you do, I will show you. So create table, so actually, so create table, table name, that means it will give completely table creation statement actually, okay? And one more thing, same thing, Srikanth, again, whether it is 5.8 or 8 series, whatever it is, InnoDB file per table, MyISM, 1 table, 3 files actually, okay? Remember these points. Tomorrow you will get more exposure actually, tomorrow class. Tomorrow only completely whatever the discussions happening, that everything, and MySQL complete class will be depends upon these two data files, these 2 table spaces. Based on that only our class will happen. Performance tuning, way of backup and restore, way of maintenance, everything will be depends upon these 2 only. We will see tomorrow these 2 actually, okay? All engines I will cover. All the people just focus about these 2 engines mainly. Yeah, today class, anyone have any questions?
That,
Sir,
sorry.
Yeah,
The
tell me.
tools
One by one,
you
one by
explained, right, Ram, the tools, GUI tools,
one.
the D4, is that free or all these things are?
See, everything free. I think
free?
few of the tools I mentioned actually like a licensed. Which one you are saying, DB Ever or what?
No, D4 something.
This one, DB Forge actually, yeah. This one we need to Google it actually, whether it is licensed or free of cost, we need to Google.
Okay.
Yeah. So yeah, I got your point actually. You can get more details, right? With this,
Yeah.
executing and
Correct.
debugging, backups. Yeah, this is good actually. Anyway, it's good only. Yeah.
Sir,
You
in
can
architecture, you showed us dispatcher. So what dispatcher does in MySQL?
Result set, dispatcher, labor, just like a labor. Optimizer like a engineer. Dispatcher like a labor. What labor will do? Whatever the plan engineer generated, right? I will not bother. Okay, whatever it happen, let it happen. Whatever the plan this guy given, I will follow that plan only. What this guy will give in the disk actually, yeah, actually I am in that assumption. All people are my PostgreSQL students, right? I am in that assumption actually. Normally disk is there, right? In the disk, end of the day, disk will be like a Excel sheet.
Yeah,
Your
this is
disk
like
will be
our
Excel sheet.
storage, right?
Storage, disk storage is there, right?
Right,
It's an Excel sheet.
right.
A1, A2, B1, B2 columns, rows will be there, right? Like this. For example, sample I will show you just 3. So if you see here, for example, this is A, column A, this is column B, this is column C. If you see here, row 1, row 2, row 3, row 4, okay?
Right.
So I can treat like a A1, A2, B, A1, A3, A4, right? This is B1, B2, B3, B4 like that. For example, I created one employee table. My employee table data, see here, for example, employee table data in A1, A2, A4, A6 locations, my employee table data stored, okay?
Right.
For example, it's stored. My optimizer is there, right? So optimizer generates a plan. Sorry. Optimizer generates plan. It will give locations. It will give, hey, that guy running select star from employee. You can go to A1, A2, A3, A4. This dispatcher is there, right? It will not even think what that guy told, who is there. It will not even told. It will say simply, the optimizer given, I went to that location, I took the parcel. Something like that, okay?
Right.
Dispatcher blindly go to the locations, A1, A2, A3, A4, A6, right?
Right.
Blindly it will take the data, where it will display. If you see this, it will send your output to here. I will show you. Line will come like this. My dispatcher is there, right? Data will be displayed on the output device, right? If you are running from a graphical tool, their output will display.
Okay.
If you are running command prompt, there. If you are running application server, there it will display the output, right?
Okay.
So it's just like a labor. It will
Okay,
not think what plan, why is generated and all. No, it will not even bother.
So dispatcher will fetch the data from down and will pass to
Correct.
the GIS CLI, right? So
No, not only getting data. If you are doing insert,
okay, right. So
if
then
you are doing
again,
insert, what will do? Optimizer will say, hey, you go and insert the data in A1, A2, A3, A4 locations.
okay.
Blindly dispatcher will take the data and update in the locations. Okay.
Dispatcher will do everything, whatever optimizer will suggest.
Everything. But who is controlling? Optimizer controlling, right?
Right.
Correct. Optimizer will you may get a doubt. How optimizer will get these locations? It will generate which algorithm? To get exact storage locations, optimizer will generate hashing algorithm.
Yes.
I think you might have this in your academic syllabus. Hashing algorithm will generate a 16-digit actual number. 16-digit number, okay? Each memory location will contain 16-digit number. This one. Here for your understanding, I told A1, A2, right? In the original disk, not A1, A2. It will be a bigger number, 00010, something like that.
It will
Right?
generate a plan number, right?
Binary format, yes. That. Yeah, someone is trying to ask some question. You people, both people, this one actually. Another question is there, someone asking. Another one also trying to ask question, right?
Right. He's asking you.
They dropped in middle, yeah.
Ram, when you upgrade.
Voice low.
Can you
Not
hear me
audible.
now?
Yes, now good.
Okay. So when you're upgrading from 5 to 8, MySQL 8, how do you do that when you said you'll remove the software and reinstall it?
No. That is minor upgrade.
Okay.
That is minor upgrade. You saw in PostgreSQL, right? Minor upgrade is different, major upgrade is different.
So how do you do that major upgrade? So 5.8 to 8.2 is a major upgrade, right?
Yes, yes. 5.7 to this one, that one you need to do manually, MySQL upgrade. That is manual. But whenever you are going with a minor upgrade, right? You no need to run. You simply remove the binaries, install the new binaries. I'm saying actually the benefit in minor upgrade.
Okay.
In 8 minor upgrade benefit is there, okay? No need to run. No need to run MySQL upgrade utility. This is one utility, MySQL underscore upgrade utility, okay? But actually for that major upgrade, complete MySQL upgrade required.
Sir, one more question.
Hmm.
Sir, why in MyISM they have 3 different files, like for index as well?
Design, MySQL design. So by default, there is no InnoDB. Initially, they built the product, right? They completely built it for separate purpose, actually, just analytics purpose only, not online, not for online purpose earlier.
Okay. MyISM not for transactional. Okay.
Not for transactional, no,
Transaction,
only
right,
for
right.
not transactional.
Okay, so
Correct.
then we can have an index, because I was thinking it is a logical. So why are they keeping in 3 different files?
That's what I'm saying, right? Earlier design was like that actually.
Okay.
Earlier, old design. So later what happened, slowly, people rising points. How you become competitor for Oracle. These kind of points came, what they done, they forgot completely for what purpose they came into the industry, right? That purpose they forgot, they introduced the InnoDB.
Okay. So
Initial
can
design, they cannot make any changes, right?
Yeah. So can we get today's, document, because it was very big topic today.
No, actually. See, and one more thing, for some people, I'm saying one thing. You may think like a Rambabu not installing software. What you will do with installing software? For that installation, you no need to come to me. Okay. It will take some time for installation. Lot of things are there, internals. First, you focus about internals. Then software, what is there? If you Google it, somewhere you can get the installation command. Okay. Don't bother about installation. Once you are installing, right, by the time, by seeing everything, okay, I know this parameter, I know this data file, I know the structure. Like that, you should have confidence. Okay. First, I'll make you people like that. Then only I'll proceed with the installation. Okay. We'll meet tomorrow. Thank you all.
Ram,
Yeah.
one
Sorry.
final question.
Hmm.
What is the temp behavior in 8.5? Will it
Temp?
create a physical temp behavior? Because as per ISM, it creates a physical structure, right?
Two
Physical
things are
file.
there. Two things are there. MySQL given 2 options. Okay. Temp space is different. Okay. Temp space, that means only for storing temp result sets. Correct, right? Temp result sets. That means if your query running subqueries, nested joins, if query generating more temp files, it will use the temp space. That is one thing. Second thing, to execute my queries faster, I can split my query. Later I will cover this one actually. Unnecessarily, people will confuse.
Okay.
As part
okay,
of tuning, this
fine,
will come.
Okay.
Very bigger query is there, right?
Okay.
Instead of running bigger query, normally I am saying why we will create the temp tables. Okay. Instead of running bigger queries and multiple joins in the same query. Okay. Same query, I can create temp table with join conditions, right? Join conditions. In my final query, I will use
Output.
temp table.
Okay.
Instead of multiple joins. Correct, right?
Okay.
If anyone asks query execution time, I will say only last steps time only. Okay. If it is taking 2 seconds, I will say 2 seconds. But earlier query is there, right? Earlier query, subquery is taking 5 seconds.
Now
Main query taking 2 seconds, total 7 seconds taking, right?
Okay.
In my case, I can save the lot of time with creating temp tables. So here 2 things are there. I kept the limit. Temp, it is giving more scope to temp tables, not a good idea. Okay. Control the temp table size also. What I am defining, hey, temp table should not be more than 1 GB. Any temp table temp table size should not cross
1 GB.
1 GB. I am keeping the limit. Okay. If by mistake your query generating more temp files, what will happen? Immediately it will be changed as a physical table. Okay.
Yes.
Physical table and creates with which engine?
ISM engine.
ISM engine. If you people have doubt, actually see later for cleanup purpose, I need to identify the tables and I need to drop the table. That is one thing. Second thing, I will keep that table. Okay. I will keep that table. Next time, if I am running same query, directly it will get from the table, right?
Yes.
Internally. If you are see, go to any MySQL 10 years or 12 years guy and you ask, hey, is there any way to control the temp table size? If yes, if it is crossing that limit, what will happen? You ask these questions. If anyone answers, you no need to pay fee. Lot of internals are there. We will cover. Okay. Anyway,
Okay,
we'll meet tomorrow. Thank
Yeah, okay,
you.
Ram. Okay, Ram. Thanks for the
Sir,
update.
So,
Yes, do
one
the
last question.
tell me.
Oh, one last question. So you said once it crosses 1 GB, it will create a physical file. So once that query is executed, and so that file will get deleted.
No, not deleted. Physical table, right? You need to manually.
Okay.
So what drawback,
Oh,
right?
manually.
That is the reason. Be
Okay.
careful. Be careful
Okay.
while using more number of nested joins, right?
Mhm.
So don't go with the
Thank
temp table approach. If you are not confident in the plan.
Okay.
I will share this image as well. MySQL architecture, right? Architecture and internals. Yep. I will share the images. Actually, still that's not finalized, right? Once payment done, whoever the sending payment for them only, they will get the video actually, video and notes. Okay. That's what. It's just like a last 3 days, just like a demo. Tomorrow onwards, regular class. If anyone wants to continue, do the payment. Even one guy also, I will take the class. Okay. Thank you. Bye. See you tomorrow.
Thank
Okay,
you.
Ram. Bye, Ram.
Thank
Thank
you.
you.
Thank you all. Bye. Bye.